Okay, everyone, welcome to Intro2Astro 2024. This is our annual 8-week long workshop into astronomy research. My name is Dr. Fei Dai. I'm currently a faculty member at the University of Hawaii, and I specialize in finding exoplanets, which are planets outside our solar system. I'm leading this workshop with Howard and Shitan. Together, we will learn how to code, which is a very handy skill, not just in astronomy, but pretty much in any other field. I'll be making plots, analyzing real-world data, and we will also learn about research papers, how to read them, summarize them, and even write papers. By the way, can people hear me? Good.
Yes.
Yeah.
Okay. Let's see. So at the very end of the workshop, we will also teach you how to apply for grad school. Many of our previous year participants are now in PhD programs in top universities. Okay, before we start, any questions? Type the question in the chat or feel free to unmute yourself.
I don't
Okay. Okay, if there's no more questions, let's get started. Our first speaker today is also our workshop leader, Shitan, who will be showing us how to use command line tool and how to use GitHub. Shitan, take it away, please.
Yep. Am I audible?
Yeah.
All right, great. Hi everyone. My name is Chetan. I'm like one of the instructors and lead for the Intro2Astro this year, as well as like I was last year there with Faye and Howard. So first of all, I'd welcome you all to this workshop. I'll be talking about Unix and Git today, and also a brief about how we go about in Python and like the Jupyter notebooks. So whatever we'll discuss today will be a very brief, and there will be assignments related to whatever we talk about, so that you can go back to it and look at them, do it at your own pace. And of course, this whole meeting is being recorded so that you can look back at this recording as well whenever you have the time and whenever you want to. I'll just quickly share my screen. Give me a second. Before we start, I'll just also like quickly walk you over with the Discord channels. So this is the Discord. If you are unaware of how to use Discord, there is a channel over here. So these are all channels that you can text and write your queries upon, or network with other people. So I think you should have already assigned the 2024 student role, and the mentors, whoever are here, should have the mentor roles as well. But if not, you can go over here and you can select these three things. So if you want to get added into a channel that you can interact with the other students and participants of the workshop, you can select this and you'll get access to those channels. So if you like get well versed with how to use Discord, I think this should all be pretty simple. There is not a lot of things going on here. It's just everything has a separate channel. So if you need some help, you can write it over here. If you want to go over the code of conduct that we have for the workshop, it's also written over here in like very short. It's be respectful for everyone, and that's all. And then we will also be like the mentors for the workshop will also be updating about their hours, like whenever they're available for your queries, answering your queries and questions. You like they'll put that over here and you can check that, and then we can regroup and join these channels. So these voice channels will be there. You can talk to the mentors over here. So you can be either on a voice call or on a video call. And I'd like really request you all to give your short introductions over this channel so that everyone over the workshop knows everyone else, and like it's a great networking opportunity as well. And then the other channels you can use as you see fit. Moving on to the Unix tutorial. So these are one of the slides that we made for an earlier year as well, and I've just updated them a bit. And these have a lot of information, but I'll quickly go through the required things for first, and then you can maybe refer to them. Also, before we start, like all these slides and everything is also present on GitHub, so I'll just quickly open that up. it's present on this link. I'll also link these all things in the Discord channel. But yeah, it's present over here. The week one tutorials are up over here, and you can go over here and you can see all the tutorials that we are going through today. Coming back to Unix. So, yep. So Unix is an operating system, first of all. And what is an operating system is something that links the hardware of a computer or your laptop to its software. And this is the interface between the two. And it was entirely written in the C programming language, which is one of the most fundamental programming language that you will interact with. And it is like used till now because it is really fast for repetitive tasks, and it can be used in a distributed manner. So once you go to like a higher computation needs where you are required to work on high performing clusters, you will be required to work on Unix. And Mac OS, as you see, I'm working on a Mac. So this is by default a Unix based system. Going on, what is a Unix shell then? So these are terms that you'll hear more often as you go into the course. So Unix shell is a command line interface as well as a scripting language. So basically saying Unix runs on some commands, and a scripting language combines all these commands into a group of commands that it can like trigger one by one. And this is kind of what the users interact with. So I, as a user, would write a command for Unix to run, that will run on the hardware. And if I write a bunch of commands, that becomes a whole script. And these commands need to be in a particular format, which is called a syntax. So Mac OS's terminal already provides this command line interface, which we can interact with and write our commands on. And Linux also has a Unix-like implementation, so all these commands would also be applicable on Linux. But for Windows, there is a special thing that you will need to do. So Windows does not have a Unix; it's a different OS altogether. For this, you can either install a Git shell or you can install a Linux subsystem for Windows. So all those are linked over here, and I think this is something that you should do because like down the course, we will be using these a lot. And this going forward, like how to do this. So I have like some examples over here, and I can also show you over the command prompt itself. Let me just open one new window. Yep, so this is a command prompt that you'll see. And over here I get the like option to input some commands. So first of all, let me input a command which is called pwd. This tells me the present working directory. That means the folder that I'm working on or the directory that I'm working on. So it prints out like it is I'm working on this particular folder, which is my folder as a user in this computer. So this is a very basic command that I used, and the OS gave me an output. Right. Going back over here. So pwd is this command. If I were to like see how this works and why this whole thing is in such a way, is because the whole Unix structure is in a tree-based structure. And what that means is my whole computer starts with this slash back. This slash means like I'm at the root of my computer or the this tree. All right, then everything going down is a folder or a file, right? That folders are called directories and files are basically files, right? And over here, if you can see like this folder, if I was in this folder, let's say I'm nil, and you can see I was going through this route to this users directory, and then from users directory to my home directory. So this is called a home directory for the user, which is I. So if I were to go back, this is my home directory. It starts with the root, it goes into the first folder, which is the users folder or the directory, and then it goes into my own folder, that is Chetan Chawla. And then if I were to move directories from one directory to another, like if I were to go into the other users directory, or let's say I were to jump back to users directory and do some operations over there or do something over there, like check the files and so on, there are commands for that. And I need to navigate through that. So like how we can move around is by changing our directories. And the command for that is cd, which is used to change the directory. If I were to like write the paths on where I am going from, like the current path, that will take me to that to that directory so that I can work there. All right. Right. So you can also see, so this basically what I have open is a Jupyter notebook. I'll talk about this in a while, but yeah, this is something that I'm working on Python. And if I'm working on Python, if I write percentage bash, it basically imitates the Unix operating system on my Python notebook, which I'll be talking about in a bit. But yeah, over here you can see I have written a command to move to the home directory. This tilde sign means that I am talking about the home directory. And if I were to like run this command, it says that I am now at the home directory. So if we do not move to our home, our current working directory should be one where this notebook is placed. And there is another command called ls, which can list the contents of the current directory. So you see, I was in my current folder, which was for Intro2Astro 2024, and I see all the files and all the directories that are present in that folder, which you were also seeing in this, yep, over here. So I was in this folder, which is why everything is present over here. Moving forward, so these are some more commands. I won't go into the details because these are all written and you can like go through them one by one. There is an assignment that needs to go through them one by one. But the like short thing about this is I can move from one folder to another folder using this command cd. And this can be on relative paths. I mean, like moving up one directory, going from one directory to other, or you can also write the whole directory path and then you can directly move to that. And these are some more commands that I like tried out. So over here we have pwd, which tells me my current directory. Then this tilde sign was the home directory. So I went to the home directory, and then so on. Again, you can go through this at your own time. I won't go into all the commands one by one, but yeah, this is something that we will see in like later uh, half. And then we have some more commands. So there are listing commands, as I talked about. ls is the command which lists the contents of a directory, like all the files and all the directories in a directory that we are currently in. The ls command lists down all the contents. And then there are some flags also. So flags are basically options or parameters that you pass in Unix. So over here you can see ls hyphen l. This hyphen l is the flag, and this means that in front of this command I am giving it some options on how to show me the data. So if I were to write hyphen l, it will list the directories and files in the current directory in a list format. If I were to write T instead of L, then it will do the same thing, but it will be sorted by the time they were created or modified. So these are kind of options on how I want to see my command work. And I can also combine these commands. So if I were to write ls hyphen lt and like this part, it will show me all the files in a list format and also arrange them by the time they were created or modified. So these are called flags, or the options that we have while running our commands in Unix. And you can see like ls hyphen ltrh gave me all my files in a particular list. Moving forward, there are some more commands that we use. So touch and a file name like creates a file. It creates a new file that we can work on. Mkdir creates a new directory. Here, this parenthesis directory means the name of the directory. Rm removes a file, and like be careful while using this command because it can actually remove everything from your MacBook or from your computer. Yep, going forward. And similar to this, like once we create a new file, if we need to edit a file, we can also enter an editor, which is also present natively on a Unix system. So you can write Nano or Vim. These are text editors. You can write anything in this like a text file and then save it. And it also has some more complex capabilities, such as it can move from one place to another. It can cut and paste things. It can find specific strings in the whole text file, and so on. And moving on, like there are some more commands about copying and moving files. So you can copy files, you can move files, as you can expect from an OS to do, and there are commands for those as well. And then we can also print to screen. So that means like if I want to write a message in my screen, I'll write a message using echo. So if I were to just write echo, let's say hello participants, this should write just hello participants. So if you all have a Mac or if you all have a Linux, you can try these commands out by yourself, and you'll see like these commands work, how these commands work. I'll just write a few more that we just talked about. So let's do cd, which changes my directory. Like currently if I were to do pwd, this is my current directory. I'm in home. Let me see what all directories are present in my home. So I'll do ls and I'll pass a flag, which is to list all the directories. And these are all the directories that I have. I want to move to, let's say, astrophysics. So I'll do cd astrophysics and press enter. That would mean I have moved into astrophysics folder. But how would I know I have moved into astrophysics folder? I can simply write pwd, and this again gives me the current directory, which is astrophysics. So these are some commands that you can try on your own. If you have a Mac or something, you can try it like alongside. But yeah, this is what Unix essentially does, and these are some more commands again. I'll skip these for now. Um, yep. So this is something that we need to talk about. So over here, give me a second. Yep. So over here you can see I have let me move this on screen. Yeah, I have a percentage sign. So this percentage sign means that I need to input something to the computer or this terminal. And this is called a prompt. It can be a dollar. It's a dollar in a Linux system. It's a percentage over here. Then I write my command, which is like, let's say I wanted to write ls, right? Then I want to write some kind of options, which are the tags. So to enter those options, I either need to enter a hyphen, and then I need to enter whatever my option means. Like I need to list every file in this directory in a list format. So I'll press L, and you can find all these by like typing help over here, and you'll see all these options. This is called an option. And then lastly there is an argument. So if I needed to go into some folder and needed to see some folder, that is an argument. It's kind of a parameter that I pass to the this command. So I want to see everything in this current folder, I'll press dot, and this will again put everything over here. So this is the structure of a whole command that is going on in Unix. All right. Please, like, feel free to put your questions in chat. I think some of the mentors or Faye would answer your questions as they arrive. Moving forward, so if I write a bunch of commands in a sequence, that becomes a script. And this script can be stored in a, let's say, a file, which is a shell file, and then it can be executed like all together. So let's say I write 10 commands in a sequence and I want to trigger them or like run them all together one by one. I can just like trigger that script. And for example, this is useful when we are working on repetitive tasks. So for example, I want to like make a script that finds all the like notebooks, the Jupyter notebooks that I talked about in a current directory by finding its extension. And then it needs to print the names. So it's a kind of a repetitive task. I need to find some files in a folder with a particular extension and then write their names. So I can do this like this, like it's a for loop. A loop is basically to iterate over something over and over. So I find those files with this particular name and then I write their names out in a particular text file, and done. So this is a script. This can be saved in a text file, in a shell file, and it can be run in a sequence one by one. Now you have your assignment. So this is basically all that we need to talk about Unix today, in a very brief. You can go through this tutorial, and then there is this assignment. You'll need to do these statements, and all these commands are already discussed in the previous slides. And once you do this, you can enter a like screenshot on Discord. There will be a folder called I think I haven't added, but yeah, I'll add a new folder over here that will have like your assignments, and you can post it over there. But yeah, this is the first assignment. You can create a new folder, then you move to that folder and write a hello world to a text file, then display the contents of the text file, make a copy, and place the copy in a new subfolder. So these are some commands that you'll find in the previous slides, and some of them we already talked about. And then the assignment number two is going through this software carpentry course. So this is a very comprehensive course about Unix, that tells you about everything that you need to do, like to learn Unix from scratch, from really scratch, from a beginner perspective. So this is a really helpful course. It would be great if you can go through this as well. And moving on to Git. So I'll first start with what Git is. Git is basically a version control system. That means, like, let's say that you're working on a project. I'm working on a project and I need to save versions of it as I work on it. So let's say I worked a particular amount on it and I saved version 1. Then I made a significant development that created some of my plots. I make a version 2. Then I go forward, I like put those plots in a particular format and then finalize a lot of things in my project. That makes a version 3. So I want all these versions to be tracked so that I can refer to any one of them at any time, and there is no hassle as such. I have like some particular messages that I wrote, like this version means that I have done this part, this version means that I have done this part, and I can always roll back to one of them. So this is what Git does. It's kind of a version control system that controls the versions of your files and your folders in a project, and it maintains this history of all these versions so that you can roll back to any one of them and refer to any one of them. So this is what a Git is. And a Git repository is this project that I'm talking about. So it's a folder with a .git subfolder. It's kind of a collection of codes and other files which is kept track of in a particular format. All right. Um, so this is for installation of Git. It's by default installed in a Mac, and it's also by default installed in a Linux. For Windows, you can download it from here. So you have the link in these slides, and you can follow the instructions simply, and you'll get a terminal similar to this for Git. For Mac, it's already present. So let me show you what Git is. I'll just go into Intro2Astro 24. So I am currently in my Intro2Astro folder. And before I start with going into the commands, I'll just show you what this means is. So I just talked about Git, but there is also a thing called as GitHub. And how are these two different? So Git is something that is present on your local machine. You have a particular project that you were working on, you make those versions and you control it over your particular local machine. When we want to talk about collaboration with other people, and when we want to talk about uploading to a website, and then keeping track of everything by multiple people and not just yourself, we are talking about GitHub. So it's a collaborative system where Git is employed. All right, so over here, this is GitHub. We have a folder which is Intro to Astro. You can see this is the folder. This is called a Git repository. So this is my project that I am working on. In this particular project or in this particular repository, I have some set of folders and I have some set of files. And like I said, we have some set of codes. So if I were to go into this folder, there are some set of codes that I have written. And over here, you can see last commit date. So all these commits are the versions that we were just talking about. So these are the versions that I committed. Like if I made a change like yesterday, it's written yesterday. If I made a change 3 hours ago, it's written as 3 hours ago. And what I made the change was, so I wrote here a message that I added week 1 tutorials. And last year I made some change, like this remains unchanged. So this was from last year, and it says that initial updates. So depends on what you are doing and what version you are on, and you can write a message and the time, and this is stored as a new version of this repository. So this is what GitHub is, and when we talk about Git, it's the same thing, but it's on your local machine. So how to connect between this local machine and GitHub? Do we need to download everything from here and work on this particular interface? The answer is no. You can definitely do this. You can go through here. You can run these commands, but it's easier to like work the other way around, which is to use this local machine to connect to GitHub. So what we all need to do is, and this is something that you all need to do, is create a folder on your computer, and you'll need to get this repository into your local machine so that you can work on these tutorials. So first of all, there is this green button that has code written over it. You need to copy this to your clipboard. This is the URL or the GitHub link for this. All right, and you can like go into that folder, and then you need to git clone it. So I'll make a new folder for now. Give me a second. Yep, I need to make it. So I made a new folder which was GitHub tutorial. I want to go into this folder. You can also do this like through your file manager. Alright, so if I were to show where I am in this GitHub tutorial folder. Now I need to download everything from GitHub to my local computer. So what I'll do is I'll write this command, which is git clone. It clones the whole repository into your local system, and then write the URL that I just copied from GitHub. And it is saying that it is cloning this whole repository into my own laptop, and it's downloading everything that is present over there. So let's give it a second till it downloads. Yep, it has downloaded. So now I can move into this folder, Intro2Astro 2024, which I just downloaded. And you can see I have downloaded this repository. I just clear the screen. Yep. So what is there in this folder? Let's list the commands. Let's list the contents of this folder. And you can see I have every like file and folder that were present in the GitHub repository. I want to like make sure that I am updated so that in week 2, whenever there are updates that are made by mentors and the instructors, I want to have the latest changes. So to pull the latest changes from this repository the next time I'm using it, it is advisable to always use this git pull command. What this does is it fetches the latest changes from GitHub to your local machine every time before you start working on it. So that if there is any change that someone is doing, you can always see it. So if I were to git pull, it will currently say that it is currently already up to date because we just cloned it. But yeah, in case there is any change, you'll get those changes downloaded as well. So this is git pull. And let's say I want to work on a file. So I'll move into CD week1 folder. All right, I'll just make a file, and the command to do that is touch, and I'll write that name github example.txt. So this will create a blank file, and let's see if it is. So it is there. I'll do lsl, and I can see this github example.txt file over here, right? So I have added a new file which is blank for now, and it is fine that it is blank. Now I want to upload this to my GitHub page, right? And how to do that, right? So what I can do is I can I can check if this is added in my git. So first of all, I write this command git add, and then add this file github example. Give me a second. So what this does is it adds this file into the files that I'm tracking to use in this folder. So git add is the command that you track your files with. Once I have added it, I want to make this a version. So I'll write git commit. This is another command. So as you just saw on GitHub, like these are all entered as commits. Right. So last commit date, these are all versions that we were just talking about. So any change that I'm making, I'm committing that change to GitHub or Git. and I write this as git commit, and then I can add a message on what this means. So added an example file so that I can refer to it in the next time. And this will add one file. So it says that one file has changed, and it created these insertions since there was no line. So it says zero insertion, but there was one file that was changed. And you can see in, so there is another command that you'll need to use, which is git status. This tells you all the things that are going on in your current git repository. So there is nothing to comment, there was no change, like we have already committed all the changes, then it says nothing to commit. If not, it would say that there is one file that is untracked, or there is one file that needs commit, and that is something that you can check one by one when you are going through this. So these are some basic commands that you'll need to use with Git, and this is the GitHub folder that you'll need to refer week by week. There will be tutorials that are here that you'll need to refer to, as well as there will be keys that will be published like a week later. So there are, like, for the assignment that I have for Unix and Git, I'll publish a key for the next week so that you can refer to it once you work on it on your own, and wherever you get stuck, you can take help from it.
So
All right,
Shaitan,
yeah, I
this may be a
think
good point to
this is
pause for
all
questions.
for the Unix and yep, sorry, Faye, can you repeat?
Sorry, I didn't mean to cut you off. I just
Yep,
thought this may be a good point to stop for questions if you're down.
yep, 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 yep. So I haven't checked the chat yet.
Yeah, I've been answering some of the questions. So folks, if you have questions, feel free to unmute yourself and ask away or type in the chat.
Yep, whatever feels like comfortable for you, you can unmute and ask right now.
So one thing I want to mention is
And
that this is a quick overview of Unix and GitHub. You're not supposed to get everything just from listening. What I suggest is, after the live session, you can go back and try these commands on your own and go through the assignments. More understanding will be on the way. We are actually doing the exercise. By the way, all the recordings will be posted on YouTube, so you can check back later and maybe follow along.
yep, and do let me know if I need to go any slower or if I need to go any faster. Like, any feedback is also fine. Oh, we'll put the YouTube videos or whatever, like the links will be posted on Discord, like once the videos are there. Can you explain what Bash means? So Bash is born again shell. It's kind of a shell scripting language. So the syntax that we are talking about, give me a second, I'll just share my screen. Um, yep. So yep, okay. So this is Bash. Bash is born again shell, and again born is the name. It's one of the most popular implementations of the Unix shell. And as I talked about what Unix shell is, it's a command line. It's both a command line interface where we can write commands, and then it interfaces with us, so it gives us an output or it does a task, as well as a scripting language. So it can combine a bunch of commands in a script, which can be triggered all together, like one by one. All those commands would be triggered one by one. And by triggering, I mean run. Like, those commands would be run one by one, and those outputs would be given one by one. So it is both a command line interface as well as a scripting language. And Born Again Shell Bash is one implementation of that. There are other implementations as well, like ZSH and so on. But again, these are all implementations. There is not, like, at the surface level, when you're interfacing with it, there is not a big difference between those. It's kind of just looking like a shell to you. But yeah, this is all about Bash. Is it possible to use Unix command on VS Code terminal? I'm not sure, because VS Code terminal is again based on your terminal of the OS, which is if it is Windows, then no. But yeah, if you want to use your Unix commands, you can definitely use this Linux subshell, or you can install the Git shell. Git shell would be like really beneficial because you'll anyway have to link or use the GitHub as well. But yeah, this is a way you can use the Unix commands. Also, as I said, like you can also, like it's written over here in a Jupyter notebook, which we will be just talking about in a bit. So it's a Python notebook where we write any commands, or it's actually not just Python. There can be other languages as well. And for example, there is a magic command over there, which is called percentage bash, which allows us to make it like a Unix like shell. So it is possible to write those Unix commands on a Jupyter notebook as well. And that won't require any of these installations. All right.
I just want to mention that in the big picture, the reason why we are learning command line interface and GitHub is in research, we often encounter a large amount of files. And your usual way of interacting with the computer of clicking the windows, copy pasting by hand is very slow. So we need to learn this method so that we can deal with large amount of files easily.
Yep. And it goes beyond just astronomy, I'd say. I definitely use it in my other job as well. So I work as a technology consultant other than working on astrophysics projects on the side. And I was a research associate back in 2022. But yeah, this is being used in a lot of systems where a lot of file manipulation is done and file working with files is done, because it is really fast and it is kind of the fastest thing that you can use to work with a large amount of files in a distributed manner. All right, I think if we do not have any more questions, we can move forward. But if you come across any other questions, you can definitely put them on Discord. There is this assignments help channel that you can put your questions on, and
Shitan,
you can use other channels.
I was thinking in interest of time, maybe we should leave Jupyter Notebook to next week. It's already
Yeah, that makes sense.
40.
Yep, we are already a bit late. Yeah. All right. I'll just maybe give a quick 5 minute intro to this and then put the rest to next week if that works. Phil.
Go ahead.
All right. So there is this tutorial that I have written, and it's a kind of a huge tutorial that you'll see. But I'll just quickly go over like what Python is, so that you can understand what you need to go through this week and what we may cover in the next week. So Python is a high-level programming language. Just like Unix, when we were talking about commands, there are commands in Python. So there is a particular syntax that Python works in. However, the abstraction is a bit more. So it works on like higher level commands. It performs tasks that are more complex than Unix in a way. It is kind of a bit slower than Unix, but it performs more complex tasks. And it is not just Python as a language in itself. There are libraries that are associated with Python that you can import. So all these libraries are kind of code bases that work on these complex statements, and then you can just write one command and then it does a huge bunch of tasks for you. And it is like pretty much covered over here. So like what is the power of Python? And this thing that we are talking about, like this particular notebook that I have opened up, is called a Python notebook or a Jupyter notebook. It's also made possible due to these libraries that I just talked about. So you can edit these text boxes. You can also run the Python commands directly over here. So give me a second. Yep, over here. So I have some commands like over here. I have set a variable and so on. Like everything is covered over here, but I have set some variables and I have done some commands on that, and I can execute it over here. So everything is, this output is also given over here. So this is the power of a Jupyter notebook. I can add in photos, I can add in graphs, and the power of Python is, so this is kind of a plot that I made. I'll cover it in depth in the next week maybe. But yeah, this is kind of plotting 20,000 stars, and like it is writing their, or plotting their positions in from Gaia. Gaia is a satellite, and you can see all these 20,000 stars would be, if I were to run this command, this would be run in a second. And this is the power of Python. With just a few lines of code, I was able to run this. And this is the power of Jupyter Notebook as well. I was able to like run these commands in this notebook itself, and the output is also here in a formatted manner, which I can interact with as well. So I can move over here and there. Yep. All right. I think I'll leave the rest to Faye.
Yeah, don't worry about this. I think we will go through this in more detail next week. In the interest of
Yep.
time, we will go on to our next topic, which is reading scientific papers. The presenter is myself. Okay, get started. So reading papers is a very fundamental part of doing research in astronomy. And the papers usually keep you up to date with the latest discovery in your field. And being able to read papers effectively will help you identify gaps of knowledge where you can make additional contribution to the field. Also, reading paper will help you improve your own writing skills. So there's a lot of benefit to reading papers carefully and effectively. So before we talk about how to read papers, let's first take a look at where can we find papers first. This is usually through the so-called NASA Astrophysics Data System, or in short, ADS. So the ADS provides access to a vast collection of astronomical literature, including journal articles, conference proceedings, reviews, and book chapters. And the ADS is a very powerful search engine through which you can find papers by, for example, the author name, the abstract or the title, the year of the publication, or keywords in the full text. So if, for example, if we are interested in the so-called super Earth, which is a type of exoplanets that I work on, you can just type the keywords here and click search. Then ADS will give you a list of papers with that keyword, and you can actually sort the papers using different options. The default is by the date of publication, but one often used sorting method is so-called citation count. The more citations a paper have, usually the more impact it has on the field. For example, the first paper here, the Transient Exoplanet Survey Satellite, is a workhorse spacecraft that NASA launched a few years ago, and it has helped us discover thousands of exoplanets. You can see this paper has been cited almost 3,000 times. So if you click on the link of the paper, it brings you to the paper itself, and there's a bunch of options. The default shows you the title of the paper, the authors, and the abstract, as well as additional information on the publication, for example, the date, and the link through which you can access the paper. On the left, there's a bunch of tabs. This one shows the number of citations on the paper and which paper actually cited it. So ADS is smart enough that you can click on these papers to go to the paper that have cited the paper you're looking at. And the reference tab shows you which paper was cited in the paper you're looking at. And there's also co-reads section, which, as the name suggests, that these are papers that are read by those who have been on this page. It's like, linked website or something. Similar papers, basically a paper that has similar topics or similar author list. And the metric shows you how many times this paper has been cited over the years, and how many times people have downloaded the paper and read them. And finally, the export citation tab is very useful. This is basically where the code is generated through the code, and you can cite the paper when you're writing the paper. We'll talk more about this when we come to writing scientific papers. Okay, so ADS can help a user locate a paper without going through a large number of papers manually themselves. You can think about ADS.
I can't connect to the Wi-Fi network.
Sorry, my Google. So ADS, you can think about it as a search engine, but for papers. But once you find a paper, usually you can click this button on the right of ADS, and that brings you actually to the paper itself. It's taking a minute for me. Maybe let's try another paper. So on the right, these are links to the actual paper, the PDFs themselves. For example, if you click the link on archive, which is another website that hosts papers in PDF format. If you click that, the paper will be loaded. Sorry, my internet is quite slow at the moment. Anyway, I'll show you another paper that I have loaded earlier. So this is what the archive paper looks like. Has the title, the author, the affiliation, the abstract, and the bulk part of the paper. So another tool I want to introduce you to is called Mendeley. So if ADS is like the search engine, the Mendeley is more like Dropbox. So Mendeley is free to use, and it allows you to download the papers and keep them stored on your own local device. And you can sort the papers into different categories and even annotate the paper. For example, this is, again, a search interface. For example, if we are interested in super Earth, search again. Particularly slow today. Let's try my library. Okay, now you can see a bunch of papers that was listed by myself. And on the left, I've organized the papers into different topics. And if you click on one of these papers, you can read them locally. So the reason why we use Mendeley is, for example, if you're traveling on a plane and you decide to read a paper to pass the time, then you can download the paper in advance, save it on Mendeley, and when you're on the plane, you can read the paper and highlight the, for example, key sentences, or even annotate the paper with your own thoughts. And once you land, Mendeley is like Dropbox. It will sync your library across different devices. For example, this is interface you're seeing. For example, I can add a sticky notes here for thoughts that I have. And, all these annotations you have made are shared across different devices. Okay, so that's Mendeley. It's a very handy tool. Now let's talk about a paper itself, the typical structure of a paper. This is a paper that was posted on archive yesterday. So it's a fresh off the oven paper. And this is a pretty typical paper. So a paper usually starts with the title that describes the main topic or the findings of the paper. And there is an abstract, usually, which is a brief summary of the paper, including the objective, the methods, the results, and the key conclusions. It should give the readers a very quick overview of what the paper is about. And usually the paper starts with the introduction section, which gives the background information on the paper and try to summarize the status of the field, identify gaps of knowledge. And usually in the introduction, the authors will pose the key questions they hope to resolve in this work. Then there's also the method section, which is shown here, the observation and data reduction. This is what the author called it. So this section usually outline how the data were collected, or if it is experimental science, it outlines the experimental design, how the data was collected. And usually after the method section, there's a result section, which explicitly explains how the data were analyzed and may describe some statistical analysis of the data. Following the results section, there's usually a discussion section in which the author interprets the results in light of the key questions posed in the introduction. And they may also discuss any limitation of the study and potential sources of error. Usually, the paper ends with the conclusion section here. Here in the conclusion, the author summarizes the key findings of the paper, and they also suggest possible future research directions based on these current results. Okay, so now comes to the question, how do we read a paper effectively? Well, my personal strategy is to start with the title and the abstract. Usually the title and the abstract should give you a very good general idea of what the research topic is and the key findings of the paper. And by reading the abstract, you should ask yourself, is this the paper I'm looking for? Is it relevant to my research? And moreover, is the finding of the paper interesting enough that I should spend the next hour or so reading the paper in detail? If so, then I go to an introduction. A good introduction should basically help you set up, help you understand the background, the objective, and the significance of the work. By the end of the introduction, you should know very clearly what key questions the authors are trying to address. And with those key questions in mind, now you should look at the figures, particularly the captions. So the figures and the captions give you a very good visual overview of the results. And with enough practice, you can determine for yourself if the presented results have resolved the key questions posed in the introduction. And with that, quick overview at the various plots, you can go to the conclusion and you can compare your own interpretation of the results as presented in figures versus the conclusion made by the author. Do you agree with the author, or do you think the authors are overgeneralizing the results? So that should conclude the first round of a quick look of the paper. If you still think the paper is interesting, then you can take a deeper dive into the paper. And this round, what people usually do is look at the methods and the results and the discussion section in detail. And you should pay attention to the experimental design, the analysis technique, and you should formulate your own opinion of the paper. Is it valid, or are the results, or are the analysis rigorous enough? So by the end of this round, if you still think the paper is exciting, then it's time to take some notes. And usually what I try to do is to summarize the key points of the paper with just a few sentences of your own words. And you should probably annotate the key plots and point out the most salient features in the paper. And you should also ask yourself, what are the key assumptions made in the paper? If so, are the assumptions warranted? If not, is there any way that you can prove these assumptions by doing additional work? Sometimes your next research project actually comes from reading others' paper and realize the shortcomings can be addressed. Okay, that's all I want to say about reading the paper. So assignment for this part of the session, reading papers, is here. You should read this paper by Li 2018, and this is the archive link. And while you're reading, you should try to do the following. Maybe highlight keywords you don't understand in one color, and maybe look up their definition. You should also highlight key ideas in another color. And you should keep general notes of the summary for each paragraph. Try to summarize each paragraph with just one sentence. And by the end of each section, you should also summarize each section with probably 1 or 2 sentences. Again, you should do the same for each figure. Maybe come up with a quick summary for each figure with 10 words or even less. And by the end of the reading, you should ask yourself some overall questions about the paper. What are the author trying to do? What are key questions being addressed in the paper? And towards the end, you should answer yourself whether those questions have been properly addressed. Okay, so there are 2 additional resources for reading papers. One is from AstroByte, and the other is actually a journal article on how to read scientific paper. So you should check those out too. All right, I think that's all for this section. Shitan, do you have anything else to add?
No, I think we're good. Just like we can reiterate that how are we going to go with the assignments and what are the to-dos for this week?
Sure. So let me share my screen again. So this is our GitHub link, GitHub page. We'll link the page on the chat, and it's also available on our course website. And for this week, each of the presented section will have some assignments. Assignment 1 is go through the data commentary workshop on Unix. Assignment 2 is go through the exercise on Git, again on software carpentry. So since we didn't talk much about Python this week, let's skip that for now. We will go back to that next week. And the final assignment is read this exoplanet review paper by Lee 2018. Once you're done with the assignments, for example, when they are doing the data commentary, you can take screenshots of the completion and share it on the Discord channel. For the paper, you can also post your annotated PDF of the paper on the Discord channel. If you encounter problems, you can also ask questions on Discord. We'll be happy to answer those questions, and maybe other participants will be able to answer too. So feel free to do this at your own time, and the formal deadline is next Monday. So please try to complete this by next session. So each week we'll have assignments like this. So try to complete it within each week. Otherwise, things will pile up. Okay, that's all I want to say.
Yep. I think we're good. We can, so I see a question. Are we skipping assignment 3? Yeah, we can, like, if you want, if you do have time, we can go through the tutorial. It covers everything. I'll be covering next week, but yeah, if not, we can definitely cover it next week as well for Python.
Oh, still see a bunch of questions regarding reading papers. Maybe I can try to answer them right now. So query is this seen in the beginning of the paper that it is a draft? How do I get to know when the final version is? Yes. So the archive usually posts both the final accepted paper and the draft. And the author usually states on the archive link whether a paper is accepted. On ADS, there's also a note on that. Usually, between the draft and the final paper, there's only minor changes. Seldom there's a large change. So you should be mindful of that, but it's not that critical. So Jerry asked, are we skipping assignment 3? Yes. Let's push that to next week. Okay, I think that's all the questions. If there are additional questions, please post it here or feel free to mute yourself. Or, We also appreciate feedback or suggestions about the live session. Is it too quick, or is it just the right pace?
If not here, you can also put your feedbacks on Discord as well. That's great to hear.
Okay, looks like people are saying it's right pace. Okay, sounds very good. We'll keep doing this for the next 8 weeks or so. And on your end, please try to complete the assignment and post it on Discord. All right, everyone. Hope you have a good week, and we'll see you next Monday or Tuesday, depending on the time zone. Same time, same channel.
Thank you, everyone.